welcome back to 100 Days Machine Learning Crash Course. Today we want to continue our discussion about decision trees and also see the example in Scalar on how should we use the decision tree, and also we will introduce to random forest. Okay, so we'll see that how should we handle or create decision trees for categorical variables. Okay, let's say if we have something like this, then we know how should we create a decision tree to classify the input data. But how should we handle the real value inputs? So maybe your x1 will be something like 2, 3, 105, and so on. So how should you handle these real valued inputs? So until now we know how to handle categorical variables. Okay, now we want to talk about real value inputs. A very simple way to handle them is to use binary trees. So in a binary tree, we actually split an attribute x at a threshold value t. Let's say it is t. So one branch is x is, let's call it x is less than t or threshold value, and another branch is x is greater than the threshold value. Okay, so a very simple example would be like this. So let's say this is year 4. If it is less than 78, then again we could split on year, whether it is less than 70 or greater than 70, then we'll say that it is good, it is bad, and let's say this is good. So this is the example of binary tree, and as you could see in here, an important point is that we allow repeated splits on the same attributes along a path. So you could see that in here we split it on year, and also again in here we split it on the year, but with different threshold values. So this is in comparison with here, we didn't have such a thing, but in here we could have the same attribute to splitter. Okay, now the question is how to find the threshold value. Okay, one way is to actually use all of the different threshold values to compare, then select the best threshold, and after that use that threshold. But it is so hard actually, we could not because in this case we will have lots of different thresholds that we cannot burden the computational cost for that. Okay, A simpler method is to sort the data based on that attribute x1 to xm. Then we could candidate the splits based on xi plus xi minus xi minus 1 over 2. So it means that if these are the data for this attribute, then we candidate here, 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 and so on to check which of them is good for splitting. Okay? To compare the different thresholds, we could define an entropy for given an attribute with threshold t, which is the probability of x is less than t times the entropy of y given x less than t plus the probability of x greater than t times the entropy of y given x is greater than t. Okay, then we could define the information gain of y given t as h of y minus h of y given x with threshold t, and for choosing the best threshold value we could get the maximum over t based on this information gain of y conditioned on x with the threshold value of t. Okay, so now we could use this information gain star to choose how should we split to create the decision tree nodes. Okay, to sum up, now the advantage of one major advantage of decision tree is that it is easy to understand, and also you could visualize it with scale-learn. So it is actually very good to gain some intuition about data with decision tree. And we learned about information gain to select attributes. We will probably hear about ID3 or C4.5, which is actually ID3 is related to the information gain that we have seen in categorical variables, and C4.5 is actually the extended version of ID3, which could handle these real valued inputs. Then we have seen that another important feature of decision trees is they are really prone to overfitting. So we should use fixed step decision trees or use pruning to making smaller decision trees, or use different trees to create a classifier. Like we will see this method in random forest classification method. But before that, let's see an example of decision trees in Scalar. Okay. Now let's open Jupyter Notebook in here. Let's create a new Python notebook. Okay, let's work with iris dataset. So from scalar.datasets, we import iris. And from model selection, we want to use cross-validation to get the score of the classifier, and to use the decision tree, we import decision tree classifier. Okay, now we could actually create a decision tree classifier. Now we just leave here as default parameters. We just specify the random state to give the same output in each run. Then we will load iris dataset. Now we could get cross-validation score of our classifier, and the dataset is iris data, and the target values is iris.target, and we will use tenfold cross-validation to see the validation scores. So as you could see now, if you want to see the full okay, now in here you could see we have a very good accuracy on the validation set. So it has a pretty good performance. But let's see the parameters of decision tree in Scalar. You could see that instead of for splitting criterion, instead of information gain, so you could actually set that to entropy. If we say that the criterion is entropy, then so in here we could say that the criterion is entropy. In this case, it uses the information gain criterion for splitting and creating the decision tree. But we have another thing which is called Gini index. It is another way to evaluating which attribute is good for splitting. And also in here you could specify the max depth, as we talked about it, to specify the maximum depth of your tree to reduce the variance of the tree. And we have minimum samples split, again we talked about it, and the default value is 4. The default value is 2. And also another important parameter for decision tree classifier is minimum samples leaf, that you could use to in order to set the minimum samples for the leaf node. And also there are some other actually parameters that you could set and tune if you want to have a good decision tree. But we will see that we could use random forest, which is more powerful and probably most of the times is better than decision tree classifier. So yeah, let's get to random forest now. Now you know how to use decision tree classifier. Okay, now let's talk about random forest and what is the idea behind random forest and how could we create random forest classifier. Okay, so it is from the ensemble method categories, and so let me to remind you what is special about ensembling some classifiers. Okay, if you remember, if we plot the error based on model complexity, then for training data with increasing the model complexity, the error will decrease. But for test, so this is for training data. But for test data, you will have probably something like this. So this is for test data. And in other words, let me to show it with another color. So when we increase the model complexity, we are decreasing the bias. So we have low bias in as we increasing the model complexity, but we have high variance in this region. And in this region, we have high bias, and so the training error is high, but low variance. So the question is, could we actually reduce the variance without increasing the bias? So we actually want to reduce the variance. It is a good thing that we want to reduce the variance, but we also want to have low bias. It means that we want to have low training error. Okay. Actually, if you remembered again, one simple way to do this is averaging. So averaging is the simplest way to reduce the variance, and while maintaining the bias. So if we call the average vector x bar, then the variance of x bar is the variance of x over n. But actually, you know that this is when we have independent predictions. So this is important to have independent predictions to be able to reduce the variance. Okay, but in reality, the problem is that we don't have actually independent predictions, and actually we have only one data set. So the problem is that only one data set is available for us training data set. And the other question is, where do multiple models come from? Okay, so we want to create some classifiers to do the averaging on the predictions. So the question is, where do that multiple models come from? And now the idea is to use bagging. Bagging use Bootstrap aggregation. What does it mean? If you remember that Bootstrap bagging is take repeated Bootstrap samples from training set D and train the classifier on that Bootstrap sample. But if you don't remember what is Bootstrap sampling, it means that if you have one training dataset D and that have n training examples, to create a Bootstrap sample, you want to create another dataset D prime with n random sample from this dataset with replacement. So you sample from this dataset, but with replacement. Okay, so in other words, if you have x1, x2, x3 in this dataset, then p prime might be something like x1, x1, x2, or x1, x1, x1. So it could be it could have the elements of D with replacement. Okay, so now you know what does bagging mean. So in bagging, we should create k Bootstrap samples. Let's call them D1 to DK. As in here, for example, we just create one Bootstrap sample from the dataset. Then we train distinct classifier on each D. So in here we created k different Bootstrap samples. Then for each of them we train a classifier on each of them. Then we classify the new input based on averaging. If it is regression, if it is the classification, we could use voting to get the output of the ensemble of models. Okay, so in other words, we could show the bagging as, so we have a dataset D, we sample from this dataset with the same size and with replacement. So this is a Bootstrap sample D1, D2 to DT. Then we train classifier C1, C2 to CT for each Bootstrap sample. Then we combine them with averaging or voting to get the final classifier. Okay, so this is the idea behind bagging. So what is the relationship between this and random forest? Random forest actually uses two sources of randomness. So it has two sources of randomness. The first one is bagging, which we talked about it, and we will talk about how random forest use the bagging. And the second random source is random input vector. Okay, so what does bagging mean in random forest? So each tree, so random forest means that is the kind of ensemble of some decision trees. So it is consists of lots of decision trees. Okay, and so the bagging in random forest means that each tree is grown using a bootstrap sample. Of training data. So each decision tree is trained using a bootstrap sample of training data. And what does a random input vector mean? It means that when you want to train the decision tree at each node, if you remember that in decision trees, when we wanted to select a node to split on the node, we consider all of the nodes, all of the available attributes or features to consider them for splitting. But in a random input vector, we actually at each node we just use the best split based on m random attributes. So we don't consider all of the attributes or features to select for splitting. We just consider m of them randomly to choose the splitting attribute for the node. Okay, so this is random forest. Here, in other words, if I want to show it graphically, it is D, which is the data set. Again, we create different bootstrap samples from this data set. Then for each bootstrap sample, we train a decision tree, and in training each decision tree we use random input vector T2 to TK. After that we use the majority vote for getting the output. This is majority vote to get the output. So this is random forest. Okay, in other words, the name makes sense actually because it has it consists of lots of decision trees. So this is the reason that it's called random forest. Okay. Okay, now you know about random forest. Actually, random forest is one of the very popular classifiers that you could use in Kaggle competition. It is really robust to noise, and also for imbalanced data set, it is a good classifier that you could try. And if you see in Scalearn, you could see that random forest classifier. It is from ensemble classifiers, and so in here we have an example that you could just create your random forest classifier. Then you feed like any other classifier. And what probably the most important factor is the number of estimators, which you could specify when you created the random forest classifier object. and you could also control the max depth, as you know, as we talked about the max depth in decision tree. And also there are some other parameters that you could tune, but the most important parameter is number of estimators. Okay, now you learned about random forest. I hope that it is useful for you and you use it in different tasks and get good results. Hope to see you in the next session. Bye.